Hi there, it's Dr. Embody with Project 11. Hey, it's our last one. So what we're doing this time is we're solving a classic problem in computer science. It's based upon what we call graphs, which is a bunch of nodes or circles with lines connected between them. And the basic idea is I have a certain number of rooms, and what's the minimum number of teaching assistants that it would take to cover all those rooms, with the idea that I can cover a room if it's an adjacent room, and I can't cover a room if it's not adjacent. And what we're going to do is we're going to take a greedy approach, which means we're going to try to see, is one TA enough to cover all the rooms? And if not, then we'll try two TAs. And as soon as we find the number of TAs that can cover the rooms, then we found the solution. And not only that, it's the minimal solution, because we start with one and then two and so on until we find a solution. Now, in any of these kinds of problems, there's lots of different solutions. We only need one of them. And it is actually related to Project 7, where we were looking at connections among friends, who's friends with whom, which is like who's connected to whom. And here we're talking about connections among rooms. And so again, we will use what we call an adjacency matrix, which says, if I'm in room 3, then I'm connected to rooms 2, 4, and 6. And we use that kind of information to solve this problem. Now, underlying this is we're requiring you to create a class, a particular sort of what we call an abstract data type. That's this adjacency matrix that holds that information. So you have to put the information in, and then you query that object and get the information out. So what we're doing as we're solving this problem is it's like, okay, I've got a TA in room 3. Which rooms can it get to? Which ones am I adjacent to? And the answer might be 2, 4, and 6. And that's the kind of information that will be provided by that, with the idea that then you can use this matrix object in an abstract sense. It's like, just fill it up. Okay, you create a matrix, and then you give it a file pointer and says, I get the information out of there, and fill it up. How it happens? Well, that's embedded inside the class. And similarly, we ask, all right, so if I have a TA in a certain room, like room 5, which rooms are adjacent to that? And then we can ask the question, all right, have I in fact covered all of them? In Project 7, we did a list of lists for that adjacency matrix. In this case, you're welcome to use a list of lists, but really, actually, no, we're going to require you to use a list of sets, because it's really the only sensible way to do this. So let's take a look at the problem. For example, here's a particular one, this example 2, and we have 6 rooms. And the question is, how many? What's the minimum number of TAs that can cover that room? We have color here, so you can see if I put TAs in rooms 3 and 5, they are clearly adjacent to all the other rooms, and we can we can say that 2 is enough, because it turns out that 1 isn't. We assume that we had tried that. So what I'd like to do is take a look at how we might do this. And just like in Project 7, I'm going to have, how many nodes? Those are the circles. Those are called nodes. How many nodes do I have? In this case, 6. And then I have my information about who's adjacent to who, much like in Project 7 we had who's friends with whom. And so you start out and you create the lists 1, 2, 3, 4, 5, and 6, and you may find it easy to have a room 0 just because this is a bunch of lists, and then never have anything in there. That's one way to do this. In fact, I found that to be an easy way to do this. And so you'll start out with empty sets in each of these, and that's that's where you can start out. And then you can go through and start reading the file. And you know there's 6 of them because, hey, we give you that information. Just like we did with in Project 7. So this says 1 is connected to 2. So just like we did before, all right, so 1 is connected to 2. Whoops, that means we put a 2 in here, and we put a 1 in with the 2. So we fill in 2 of these. 1's connected to 5, so 1's connected to 5, and that means that 5 is now connected to 1. So here's my adjacency matrix. So this is a matrix, and we've done this by reading the information in. So that's one of my methods. And now we can ask questions of this, such as, okay, so who is adjacent to 3? Oh, that's 2, 6, and 4. Who is adjacent to 5? That's 1, 2, and 6. And so my matrix will give me that information. So as I say, so I can go through and check TAs in all these different rooms, and then say, okay, if I have TAs in 3 and 5, is that sufficient to cover all the rooms? And if I do the union of these, I see I have 1, 2, 4, and 6, and oh yeah, let's not forget the actual rooms 3 and 5 in there, the 2 rooms that I'm at. And now it's like, okay, I got 1, 2, 3, 4, 5, 6. Okay, I have them all, and so I now have this covered. But my matrix is what stores the information, and then I repeatedly try to get information out of that. And so for this class, I have I give you the outline of this, and I actually filled in some of these. So this one's already done. You can add to it if you want, but we initialize the matrix to be empty, and the rooms, those are the 2 pieces of information. The reading the file, hey, that's just like what we did in Project 7. You can do that. That's what I just showed you here a moment ago. To be able to print things, you have the str, and by the way, an str always returns a string, so I helped you out here. I said, initialize it to be empty, build a string, it'll have carriage returns in it and so on. That represents the matrix. That's what we see printed out in our examples. This one's done. You don't have to do that. That's so I can refer to the matrix in the shell. The adjacency, that's what I showed you a moment ago. If I provide it with room 3, what's the set that's associated with that? I think in our case it was like 2, 4, and 6. That's what gets returned. And then simply with rooms, we want to know how many rooms are in there. These 2 turn out to be one-line things. This actually is very similar to what you did in Project 7. It's not exactly the same. And then you'll have to think a little bit about that one. How, in fact, do you use the matrix? Well, if you look at the function test, that tells you a lot about it. You open a file, and then you create a matrix. Now, you actually, because this is in the test one, we needed to have the proj11, but you won't have that in there. And then you can say, all right, my matrix, which I called M, which is a stupid name for it, and you shouldn't use that because you'll get deducted for that. But I get to do that. And so my matrix, I can then call the read file method and pass it the file pointer. And then I can print it, and this, what I say print M, it goes to M and it calls the ._str method. So that's really testing the _str. And then I want to find out who's adjacent, so who's adjacent to room 2. And then how many rooms are there, and we print that out. So I have this object, which I call my my matrix, and then I can do some things with it. I can read it to fill it up. I can find out who's adjacent. I can find the rooms. Oh, and I can also print the stuff. So you will now use this to solve the problem. And what do we have to do with solving the problem? Well, as I mentioned before, we're going to use the greedy algorithm. And with that, we're going to try it with one TA, and then two TAs, and three TAs, and so on to see if you find the solution. And what does it mean to solve the problem with the TAs? Well, that's try all the combinations of TAs in those rooms. And we help you out a little bit because there is this thing called iter-tools combinations. So for example, if I have 5 rooms and 3 TAs, where might the TAs be? Well, they could be in rooms 1, 2, and 3, or they could be in rooms 1, 2, and 4, and so on. You know, they'd be in rooms 2, 3, and 5, or 3, 4, and 5. And this has all the possibilities of where I can put 3 TAs. All right, so now if that's where I put the TAs, how do I know if that's the solution? Well, I find out which rooms can be reached by a TA in room 2, which rooms can be reached by a TA in room 3, and which can be reached by a TA in room 5. Combine all those, which is union. I originally had intersection. You used intersection in Project 9, I believe. You just find the union of those 3 sets, and that tells you that now is a set of all the rooms reached in combination with there. And I'll let you figure out what the Boolean is to do that. But once you solve it, you then I put a note in here is that you have to be a little careful because now you might be in 3 nested loops deep, so you'll want to have a Boolean so that you can break out of all 3 loops. Because remember, if you have a break just on the innermost loop, that isn't enough to get you out of there. So there's a little bit of an idea of there's some ideas on doing this. The function test, it really should say method test, but it fits with my testing routine. That shows you how to use the matrix, and then you now have to try all the possibilities, right? And that's what the combinations let you do. We try one TA, all the different places they can be, and then try 2 TAs, and then 3 TAs, and you work your way through it that way. All right, good luck.